Hello everybody and welcome to Data Engineering Stuff. Today we're going to talk about unit tests in data engineering. To start things off, we need some definitions for our diagrams. The first is that we color code that is executed in gray and unit testable code in orange. So most of the time in data engineering, we are programming batch jobs. That's really simply the case. I know stream analytics and stream transformations is the way to go, but in practice, we don't see that too often, at least for me, that's the case. So let's have a look at how we often see batch jobs being programmed. Most of the time, these jobs look like that. There's a start of the job, there's an end of the job, and in between there's a big ball of mud. There are SQL selects, database connect, some transformation code, some Spark code. It's all over the place. You can't avoid to use any framework there for any code file because everything uses everything. So it's just everything tied together. There's no clear separation. And you will see there is not a bit of orange in this diagram because if you create such a tightly coupled system of libraries, dependencies, you won't get 3 or 4 lines of code running if you don't have like a database connected or a Spark server running. So that's really a bad idea to unit test stuff. So I will show you perhaps a better approach. When you program a job or any program, think of your main code flow and then think of calling into separate other modules. And these modules should have one task and they should have the least possible amount of dependencies. So this data transfer code, for example, perhaps it has some database configuration. It can send SQL to a database. It can get it back, transform it to, don't know, a pandas data frame or something like that, and then handle it back to the main code flow. You can argue that pandas perhaps is something we use really regularly, so it's no problem to use this in our main code flow. So we can get the pandas data frame back. We handle it to the transformation code, which is completely free and unaware of any database connections or Spark or something like that. We try to program something here that is really its own unit, so its own module with its logic that only gets like a data frame in and puts the data frame out, or it gets 2 data frames and some other parameter. And that's simply all this transformation code should handle. And then it handles its result back to the main code flow. Then perhaps there's again some transfer code because you want to write the result back to a database or something like that. And then your batch job ends. Now you see in this case, you get quite a bunch of orange parts here because now you can test your main code flow. So you can assure in unit tests, which is really handy because it immediately gives you feedback without testing it on any infrastructure, if your main code flow does what it should do. So for example, you could define in a unit test that these data sources should be used and they should be used in this order, for example. The next point could be that the result of all these 3 data sources should be handed over to the transformation code. Then the result should be written back. This you can write down in a unit test that every time you execute the main code flow, that these basic steps are done. You will see that in practice you need a lot of code more in your main code flow to handle specific stuff. There will be configuration stuff. There will be differences between dev and prod and so on. But your unit test can focus on the main things that needs to be done and can assure that they are all done correctly. Now the best part is your transformation code. You can write unit tests for every logical method in there that takes, for example, data frames, compares them, merges them, aggregates them, and get the result back. It's really easy to test them because this code has no dependency to any integration code or to any code that needs a connection to a database or some other environment. The other advantage is that you could test different scenarios. For example, what happens if one data source just didn't emit any results? How does the transformation code handle this? How should it handle this? Should it result in an error or should it result in empty result? So how should that be done? Or how do you handle like missing fields? Perhaps there is some fields that are optional. Perhaps you didn't think about all the possibilities and all the combinations that could happen here, and your unit tests can help you with that. And the best thing is, if you're once written a unit test for something, you are forever sure that this works correctly. What I really can recommend is use something like test-driven development. So if your job has a bug, so something doesn't work, and there's really a logic flaw that you need to fix, try to write first a unit test that exactly reproduces this bug, and then fix the bug, because that assures that you will never run again into this bug anytime, because there's always this unit test that assures that this won't happen again. Also, one note from my side, unit testing really saves you time. I know it's effort to write all the unit tests. I know it's difficult to really split out these parts that can be unit tested and are not integration code. I know as data engineers we are near to infra topics and we do really much things that are tied to the infrastructure, but try to modularize your code so you can write unit tests, because once you have written the unit tests, they will save you so many time in fixing bugs. And yes, I can only recommend using it as much as you can. So hopefully that helps. And yes, try to use unit code in your code. It really helps you. It really saves you time. And I can only recommend it. Thank you.